Momentum in collisions. So these are the infamous cart problems. I've got a cart rolling down a track with some initial velocity. It has a mass of m1, call that v1. It strikes a second cart which has a velocity v2. And again, the important thing to remember here is that momentum is a vector. So let's imagine that this guy actually has a velocity in the negative x direction. So the momentum before the collision is going to be m1 v1 plus parentheses m2 v2. And then after the collision, we're going to assume that what happens after the collision is that these two cars, or two carts, get stuck together and then move off with a common velocity. And in reality, it's probably a small little, it's probably a small velocity. Now, so this looks like m1 plus m2, and again, I like to call these v prime, so I'll call that v prime. So that's relatively straightforward. Another option is, and this is actually typically an inelastic collision, which means energy has not been conserved, but it's something we haven't really talked about, but we will in a couple of weeks. The other option is I have two carts that are moving m1, v1, and then I've got this guy who's stationary, has a velocity, has a mass of m2. And if you stop and think about it for a second, if I have a light cart hitting a heavy cart, I've got a small car running into a stationary heavy car, you can kind of envision what's going to happen. In my gut feel is going to be that this guy is going to bounce off, and this guy, the second cart, the heavy, the big Mack truck, is going to move, but it's going to move with a relatively small velocity. So we're going to put some numbers to this. Okay, so let's imagine that this guy has a velocity of 10 meters per second. This guy has a mass of 10 kilograms. This guy has a mass of 90 kilograms. And it turns out, and this is something that you have to do conservation of energy to figure out. This guy is going to move off with a velocity of 2 meters per second. And we can calculate what v1 prime is by setting up the equation. The initial momentum, p0, looks like 10 kilograms times 10 meters per second. And that's going to have to equal v1 times 10 plus the v2, which is 2 meters per second, multiplied by the mass of that cart, which is 90 kilograms. So this looks like 100 kilogram meters per second is equal to v1 times 10 plus 180 kilogram meters per second. So you can see that this is going to give me minus 80 kilogram meters per second is equal to v1. This is going to be divided by 10, which says that v1 is equal to minus 8 meters per second. So this guy comes in fast, 10 meters per second, and bounces back at 8 meters per second, and this guy goes off at 2 meters per second. So for this problem, we've assumed that energy is conserved and that makes it an elastic collision.